Okay, guys. Can we do the deployment parallelly with you considering? You can do that, man. But don't do it in a way that you miss the points which I speak about. Yeah. When will you start PowerShell DSC class? Okay, let us start immediately. Okay. Yes. Dhananjay, I think I have to start it, but when I'm not sure whether there will be a class directly or whether it will be whether it will be a YouTube session. I'm not sure. Okay, so you will definitely have a PowerShell DSC practice session. Class whether you will have live or whether I'll give you a link to the YouTube. I'm not sure because the problem is I have too many things to solve now. Right? Yeah. K8 is complete. Yeah, it is complete. So many one more thing. Today Kubernetes activity of mine is done. Okay? Kubernetes అయిపోయింది అన్నమాట నేను వాడచ్చు మీరు వాడకూడదు. Am I clear on that? Yes. Kubernetes అయిపోయింది రేపటి నుండి సైట్ రిలయబిలిటీ ఇంజనీరింగ్ అది నా గొడవ. That is my problem. Whether your Kubernetes is completed or not depends on whether you are able to do whatever I am able to do or not. Right? Just because it is Sunday, last day of Kubernetes is for me. Right? Okay? So for example, I have not practiced Docker. Don't tell Kubernetes is complete. Kubernetes is complete for me, not for you. Okay? Right. So let us get started. So let us look into today's agenda. What is that we'll be doing? And okay. Fine then. Okay. So yesterday itself I said that. Okay. Today it is journey of OpenMRS. To be very specific, I'm using their core application. Okay. They have various different applications. I'm using a core application. Okay. From okay. Code to Kubernetes. Okay. And environments, we'll be trying two environments. One is AKS, or let me full write it, Azure Kubernetes Services, AKS. And the second one is Amazon's Elastic Kubernetes Services, EK. So this is going to be our environment. So what are the steps? First, okay, understanding how OpenMRS works. Okay, creating Docker files, for OpenMRS and its components. Okay. Now creating Kubernetes clusters. We'll be creating two. One is AKS, other one is EKS, right? Or creating Kubernetes specs for deployment. This is a basic story, right? And as I said, you should be able to speak about this in your interview. The only difference being, today I am calling all of this from command line. In reality, you will be doing this from your CI/CD engine. So you should, for the people who have finished Jenkins, you should be able to do all of this from Jenkins, right? But for the people for whom Jenkins is not done yet, wait. When we learn Jenkins, don't forget to do this activity from Jenkins. Clear on this? Right. So now let me speak about open MRS. ఇంటర్వ్యూకి వెళ్ళి ఓపెన్ ఎంఆర్ఎస్ చేసానని మాత్రం చెప్పకండి. ఓపెన్ ఎంఆర్ఎస్ ఇస్ అండ్ మెడికల్ రికార్డ్ సిస్టమ్. యూ జస్ట్ రీప్లేస్ దట్ ఓపెన్ విత్ సమ్ యువర్ కంపెనీ ఇస్ బిల్డింగ్ ఏ మెడికల్ రికార్డ్ సిస్టమ్. రైట్? కాపీ కొట్టినా దొరకకూడదు. క్లియర్ ఆన్ దిస్? యా. పందెంకోటి సినిమా చూసారా? మీరా జాస్మిన్ సినిమాకి వెళ్తుంది, దొరుకుద్దా? రైట్, దగ్గరికి అలాగే బిహేవ్ చేయండి. రైట్. సో ఓపెన్ ఎంఆర్ఎస్ architecture or OpenMRS core architecture. So here what happens is OpenMRS is a Java based application, okay, and this application will be running on, okay, a Linux or a Windows machine, but you'll be using a Linux machine. All right, on top of Linux you need to install okay, you need to install yeah, let me put OpenJDK. You'll be installing OpenJDK, okay, and then once you have OpenJDK, then or any Java flavor, it does necessarily not OpenJDK, it can be any Java flavor, it can be Oracle JDK or IBM JDK also, right? And then we need an application server, and that it supports 2 application servers, or it should work in every application server, but the documentation speaks about 2 application servers. One is Jetty, the other one is Tomcat. So in this we'll be using a Tomcat flavor. So am I clear on this? Okay. So you have a Tomcat, and your Tomcat will be running your Open MRS. Am I clear on this? So for the Open MRS to work, your application needs to have a Java, your application needs to have Tomcat setup, and on top of Tomcat, it will work. And to be very specific, the minimal versions which these guys speak about is OpenJDK is 1.8 and Tomcat 8. Okay, so it can work on the next versions of it also, but this is what they have tested on, and this is what they are basically releasing, right? Okay, and now along with that, they will be having one more machine. In our case, that will also be a Linux flavor. Okay, and in that Linux machine, they will have MySQL, and now your application, whenever it has to work, it will interact with MySQL. Okay, and your users might directly speak to OpenMRS, whether you put a load balancer there, that is all your design. Okay, but at a bare minimum, for this application to work, this is the architecture. You need to have 2 machines. Okay, one with database, the other one with an application server. Generally, you will have a load balancer in front of it. Okay, but right now let us speak about a single machine scenario. Am I clear on this? Okay, so in yesterday I've given you a documentation there. The one difference was, here I'm taking a Java based application, there you have a Python's example. That is a Python Flask based application which basically runs over there, right? So tomorrow if you take another technology, the only thing that changes is these 2 layers, right? And on which port this applications work. Generally it works on 8080 and MySQL works on 3306. Clear on that? Yes? Okay. Right. So let me take an image of this. All right. Save this image. Okay. 120 Kubernetes. Okay. I'm not writing any other stuff. I'll directly give a reference to this image. Cube 15 kada? Okay. Right. Then what is the next step? Creating Docker files. Okay. So Docker file creation. Okay. So open MRS GitHub. Let me go over here directly. So if you look into it, this is the project which I am referring. Okay. This is the code which your developers are writing. Okay. Now what I'll do is C drive temp. Okay. Let me not use temps now. Okay. Let me remove all of this nonsense from here. Okay. So what I'll do is, don't worry about the git commands, you need not know them. Okay. So generally I'm trying to tell the position of Docker files also. That's where I'm trying to write this. Right. Now if you read the documentation over here, you will try to tell how to build the code, how to clone the code, right? So if you want to deploy in a dev environment, what are the commands which you are supposed to run? I'm using all of that, but I'm building an end release to that. Okay, I'm not going with this options. Right. So cd open MRS and let me open my Visual Studio Code over here. Okay. So over here for open MRS, I need a what do you call? I need an Docker file, right? So on the root directory, I'm creating a file called as Docker. Okay. And now what are the requirements which you want? We want a Java 8 to be installed. Okay. And if you remember yesterday's class, I said that even for building the code, I'll be using Docker. Even for building the code, I'll be using Docker, right? So remember the multi-layered image build, multi-staged image build. That is what I'll be using. So I'll go to Docker Hub. In Docker Hub, I have the image already written over here. That is because I said that it takes a lot of time. Yeah, right. So I want something with Java 8. So is it Java 8? Yeah, if you look at the Java tag version 3-JDK-8. So I'll be writing from maven -3-JDK8 and then label. Okay. Why is it going to the next line? Other. What is that extension that is killing me? ఏదో ఎక్స్టెన్షన్ బాబోయ్ ఇవాళ క్లాస్ అయిపోయాక విజువల్ స్టూడియో కూడా అన్ఇన్స్టాల్ చేశాను. మొన్న దీంట్లో ఏదో డెవలప్మెంట్ క్లాసులు జరిగినట్టున్నాయి, ఇష్టానికి కొట్టారు. అది మనతో ఆడుకుంటుంది ఇప్పుడు. రైట్, 1 minute man, let me disable disable okay. I'm disabling all the stuff, so I don't want to be interrupted. That's the reason. Disable. Disable. I don't want any of the extension to be working. Okay, we might need YAML. Let the YAML be here. These things will not hurt us. Okay, fine. Whatever labels which are required for you, you will be basically writing it. And remember, while writing any of the stuff, there is no need for you to remember anything. Docker file, instructions, go over here. If you know any of the command which I have to use, for example, I'm using label right now. There is a label over here, and it speaks about examples of it, right? So I'm following this pattern. Any of these patterns will work. I'm following this pattern. Always have a habit of going to the documentation. There is no need for you to remember anything, right? And now, the first thing which I'm supposed to do is I'm supposed to clone the code. So git clone. Okay. So what is the code which is available over here? What is the repository stuff? I'm building the code from here. Okay. And run or not cd open mrs -4, and then I have to run a command called as mvn clean package. And generally, whenever you are building the code, it is always a good idea to give a name to your stage. So let me call this stage as mvn. So once I build the code over here, if you go through this documentation or if you have done this manually, it will tell that, okay, let me show you that. Are you seeing? In the folder, there will be a folder called as web app. In the web app, you will have target. In the target, you will have openmrs.war. And this is something which we want in our Tomcat. Okay. So I'll go to the Docker hub and then I'll say that I'm interested in Tomcat, and remember I want Tomcat 8 which runs on Java 8. Okay, so let me click on Tomcat. Okay, so if you look over here, are you seeing this? This is the Tomcat 8 version which works on Java 8. So I can use Tomcat :8. So here from Tomcat :8. You can put your labels if you want. Yeah. Any other labels, whatever your team basically wants. Okay. And then we have copy --, from what is it? Maven. Okay. And here also, if you don't remember the stuff, Docker multi-stage build. Whenever you use a multi-stage build, okay, your Docker has given an given an example. Are you saying copy from, and I'm using this. I'm using this stuff. So right. So copy from. Generally, in the root folder, you will have a folder called as openmrs -4. Right, and in this we will be having. You got the path from the documentation. Right, so you'll have web app. If you look into this, are you seeing web app? In the web app, a folder called as target will be created. So I'm writing web app target openmrs.war. And where should I copy this file to? right? If you go into Tomcat, in Tomcat, the Tomcat is present in user, local, Tomcat. And in here we'll have web apps. In web apps, the copy the file to openmrs.war. And to make this application work, we need to expose 8080 port. And now I'm quite sure that we have looked at where is this Tomcat. Okay. So if you click on this, this is the Tomcat's Docker file which we are using. We have to use expose, and there is no need for you to write this CMD, because if you don't write a CMD, it will take parent CMD. Okay. So, but if you want to be clear, or if you want, this is only for documentation sake. Because your parent is Tomcat 8, whatever CMD of it will be automatically applied. But it is a good thing to basically do it. Done. So my Docker image is complete. Okay. So this is Docker file for your OpenMRS. But remember, we have one more thing to worry about, which is MySQL. Right? So I'll go to the Docker Hub again. Where is Docker Hub? And in Docker Hub, I'll search for an image called as MySQL. Okay. So whenever I'm worrying about database, I have certain things to worry about. So I need to know what is the username, what is the password, right? And I need to know if there is any database which I can create. So you go to MySQL. And there are many versions over here, but I'll be taking a 5.6 version. This is a stable version, right? So if you go over here, you will have whole information about it. Okay. And also don't forget to read the documentation from here. So how to use a MySQL image? How can you connect to a command line? Okay. So whenever you want to write custom configuration, what will happen? What are the different environmental variables that are present? Are you seeing environmental variables? MySQL underscore root underscore password. Whenever you set this environmental variable while you are building the image, it will set the root MySQL's password. MySQL underscore database, your initial database. MySQL underscore user, MySQL underscore password. And there are some other areas. So to set the username and password, do I have the ground? Yes. So, and one more thing is, if you get into MySQL, the image which I have opened, okay, so are you seeing there is a volume called as varlib MySQL? This is where whole of your MySQL data is present, right? And you can take the backup of this. Okay, whenever you want to run my new MySQL container with exactly same data. That is what he's trying to tell. So we have all the information now. So I have a Docker file, right? And then I know how to run a MySQL. So if I run both of them together, my application should start working. Okay, right. So now what is your next activity, right? Where is this documentation? Okay. For Open MRS 4. Right. For Open MRS core, our stuff looks something like this. This is a Docker file. Now build the image and push the Docker image to Docker Hub. You can do it to your registries also. Okay. So how to do it on AWS registry and Azure registry? Yesterday I have given you a link there. If you have an AWS account or an Azure account, the steps are mentioned there. Follow that. Okay. But there, what changes is how you log in into the registry changes. It is not simple Docker login. You have to do some things before that. Right. So now what will be the command? Docker image build -t. ఎంతమందికి ఫాస్ట్ గా అనిపిస్తుందని వాళ్ళు చేసేది? How many of you are feeling that whatever I am doing today is looking fast? ఎవరికి అనిపించలేదుగా? గుడ్. ఓకే, అనిపించినా నేను తగ్గించాను, కుదిరితే ఇంకా స్పీడ్ పెంచుతాను. ఎందుకంటే మై ఎక్స్పెక్టేషన్ ఇస్ యూ హ్యావ్ నోన్ ఆల్ ఆఫ్ దిస్. ఓకే, రైట్. This is my Docker Hub's user account. Okay, and then I have to give a name of this image, OpenMRS-core. And the version of the application which I am giving is, I can give any tag. I am calling it as 2.4.2 because that is what the applications version is. Okay. And then I'll use a dot. And after that, Docker push stuff. Am I clear on this? Yeah. So I do this. And the next step is, okay, how to run MySQL image on Docker. So for that we'll be saying Docker container run hyphen name. Okay. And name will be MySQL. Okay. And let us go to this. Where is that MySQL image? Yes. In MySQL, are we seeing some environmental variables? For my application, I need to give username and password. Yes or no? So let me start setting that. So -e. Okay. MySQL underscore root underscore password. Okay. I'm setting the root password as password. Okay. -e. MySQL underscore initial database equals to open MRS. You can give any other database name also, that's fine. And -e, do you want to create a new user? Yes, I want to create a new user. And let me give that new user as, okay, what should I give? Let me stick to the documentation. Let me give it as my website's name. Direct DevOps. Okay. So what is the password of MySQL underscore password? MySQL underscore password equal to, can be anything. It should be sensitive or it should be decent one, but I don't remember the decent one. So my username and password is the same thing. Okay. Now, if you want to expose MySQL connection to the outside world, you can use -p 3306:3306. I don't want to expose my database to the outside world. That's why I'm not writing -p. I'll basically say MySQL:5.6. This is a command to run your Docker. Okay. The earlier command, if you say Docker container run -d -p 8080:8080. Okay. So here, now let me write it. How to run OpenMRS core on Docker. Just look at that stuff. Docker container run --name open MRS. Okay, did I write -d over here? No. Yeah, I have to do that because generally whenever we are running applications, we run it in a detached mode. Okay, so -d and then -p 8080:8080. But if you don't know the ports, you can use capital P also, right? And what else do I want? I don't need anything, I think. So then I'll be writing my Docker image. So open MRS -core 2.4.0. I can do this. All right. If I have to run both of my containers in a Docker, this is what I am supposed to do. But my intention is not running them in Docker. My intention is running them in Kubernetes. All right. So when I run in Kubernetes, now look at this architecture. Okay. So I have two parts of my applications. One is MySQL, the other one is, yeah. So ideally, I will have two deployments, one for MySQL and one for, yeah. Okay, and then remember, if you remember in deployments, basically what we write is we tell how many replications do you want. So I'll be telling how many replications of OpenJDK or how many replications of OpenMRS is what I am looking out for. And then I will be running a MySQL. But MySQL, if you remember, there is some Docker volume there. There is some Docker volume there. So whatever data which we store in MySQL should be available throughout the lifetime of a cluster. Yes or no? Yeah. So for that, I need some kind of a persistent volume. I need a persistent volume, right? So I will be, if you go with a manual approach, right? If you are running Kubernetes in your office, first create a persistent volume, then create a persistent volume claim and make it attached to your stuff. But today the environments which we are using is EKS and AKS. There we have a support for dynamic provisioning also. So when you make a request, a disk gets created and that disk can be reused. So basically the things that are left right now is we can run these commands and then check whether it is working or not. Basically that is the work which you do. I am confident that it would work. Okay, I am not testing it. But when you do any activity, please ensure that they are working. Okay, and to access this application, you have to give 8080/openmrs. Okay, let me just, okay. If you want running this, okay, after this, don't forget to access the application. Okay, don't just say http:/, okay, whatever is the IP address of your node, right, or of the Docker playground, :8080. This will give you that 404 error or whatever error which you get. That is a feature of the containers now. And over here give open mrs. Then your application will start working. Okay. Now Tomcat has disabled that home page across all of their containers. What they do is if you give the home page, it will not show anything. It will show you the error. If you really want to see something in Tomcat, what they expect you to do is they expect you to deploy some application. Deploy చేసే వరకు వాళ్ళు ఏం చూపించదలుచుకోవాలి. That's how the Tomcat container has been redesigned. So now this is how you access your application. And that application internally has to configure to speak with your MySQL. This is a basic intention. Am I clear on this? Yeah. Now do we have all the ground? We have an application. We know how to run that application. Now what is left is how to get it run on Kubernetes. So now setting up Kubernetes cluster. Okay. AKS Kubernetes cluster. Okay. First I'll be doing this in Azure. Then I'll do it in Amazon. Okay. So for this, what I'll do is, okay, for setting up AKS. So I'll follow Microsoft's documentation. Okay. AKS Azure AKS documentation. Okay. You can create this cluster using CLI and using Portal. I'll not be wasting my time. I'll be basically using a CLI. So I'll log in into Azure. I'll be using the Cloud Shell and I'll be following whatever document basically asked. Okay. Am I clear on this? So this is for setting up AKS from Azure CLI. All right. Okay. Now let me log in into my Azure portal. Okay, let us set it up. Okay. Because this is all copy paste. You have to create a cluster. Yeah. Whenever I am setting up AKS, what does it mean? Master is not managed by me. Master is managed by Azure. And you will be owner of nodes. And since you are on the cloud, what you do is you pay for nodes. Right? In the case of Amazon, also the story is same. Right? You go to the Google Cloud, the story is same. Master will be managed by the cloud provider, and you will be managing the nodes. Okay, and then you will have instructions on how to set kubectl. Let me get into resource groups. Okay. Let me delete certain things because you will get the same view. I can go with this, but for the people who have an Azure account already, then man, delete resource group. Let us wait till this resource group is deleted.
So we will talk about the forward exception. I will define the forward.
Ah. Hmm. Why do you want to edit that? Are you working on OpenMRS here? Are you working? What is your intention? Tomcat, worrying about Tomcat or worrying about OpenMRS? And why will port be a conflict? Port will never be a conflict because you will run single application inside a container and container has its own IP address. Now, why do you want to change ports? You change the mapping of that ports, right? So if you are trying to change the ports of the Tomcat, that is something because you have to run multiple applications inside one Tomcat. That is where you're not doing that now. Each application will be running inside a container. You really don't need to do all of that stuff. That is required whenever you're doing it on a VM. I have a VM, I want to run OpenMRS, I want to run some 30 applications on the same Tomcat. That is a older way. Now what we don't do that. We write very simple containers, right? So if you don't make, if you look at the trend now, people are not even using Tomcat, they are using Jetty, which is much lightweight than what Tomcat is, right? So all of these problems are resolved with Docker because each container will get an IP address. If you have 3 applications that have to be run on Tomcat, don't do it on one Tomcat container, do it on 3 Tomcat containers. So that means 3 Docker images. And across 3 Docker images, you will never have a conflict. But still, if you want to do that, it is the same thing. Get into the Tomcat, you will see that file and you change it, but that is all unnecessary in this world. Yeah. Right. So I'm removing this because if I don't remove it, whatever you do and whatever I do might basically look different. Yeah, it is done. Fine. So let me go to the resource groups. Right. And I'm following the documentation over here. Are you seeing he tries to tell that click on Cloud Shell? Okay. Since I know a little bit of Azure, I'm basically able to move quickly. That's it. Okay. So are you seeing this? This is called as Cloud Shell. Okay. So what Cloud Shell is, there is no need for you to install any CLI. You can basically run Azure command line from here itself. That's what it is trying to tell. Okay. He's asking, you don't have any storage for this shell? Do you want to create it? Just say create storage. Okay. So if I didn't have removed that, it would not have asked me this question. It would have directly shown me the shell. That's the reason why I'm basically showing you this. Okay. Let us wait till this is created. And then from here, what happens is from here itself, you can run CLI and you can run Azure PowerShell also. There is no need for you to install anything. You can do it from here. Not a very good area. Generally, when you are working in your offices, you should have CLI installed on your laptops and then work on it. But right now, let us not focus on the simulation part. Let us focus on what we can do over here. So, right. Yeah. Not able to see my screen. Please retry again. Serious? Seriously? Okay, it has succeeded. Okay. So once you click on that, yes, you should be getting something which looks like this. Okay. Oh man, if cloud drive won't be available, it is nonsense. 1 minute. Let me do one thing. Because if cloud drive is not available, we will not be able to store anything. And remember in Kubernetes, we will be writing all the specs. I'll be uploading the specs to here. Okay. ఇది క్రియేట్ అయ్యేటప్పుడే ఫెయిల్ అయి ఉంటుంది నాకు తెలిసి. Yes. Let us wait till it is deleted. You will have these problems. You can't help it. Because if you don't have that cloud drive, you cannot store anything in that. If you can't store anything in that, you cannot store kubectl's configuration also. Then nothing works. It's a whole idea. ఏం ఏడిచింది ఇందులో ఎంత టైం తీసుకుంటుంది? Let me do one thing. No, still present. I will delete this one. Otherwise it will not work. నన్ను ఎవరు డిలీట్ చేశారు అజ్యూర్ లో రిసోర్సులు? మీరేనా? నన్ను చెప్పాను కదా సార్ డిలీట్ చేయమని. 10 నిమిషాలు సేమ్ అవుతుంది మనకి. You have to wait till this is completed. Otherwise, I can't proceed. It will fail unnecessarily after we set up everything. Yeah. Is deleting. Let us basically look into what is OpenMRS core. It is some application. Think of it as an application which our developers are developing. Right. We have not Jenkins, not done Jenkins. You will do Jenkins. Don't worry about it. If you have not done it, fine. Today there is no Jenkins dependency, right? Yeah. Kubernetes, our practice is not done. Very good. Congratulations. Will you cover application monitoring? Why will I cover application monitoring when I am running Kubernetes? That is our next 2 weeks responsibility. Right? Yeah. So Gafur wanted to cover deployment along with me. Now he is left. Right? But yeah, in the time and this control. Okay, man. While it is taking time, let us do one thing. Let us try writing our Kubernetes specifications. Okay. So now I have an application. I know the commands how to run them, and let us write Kubernetes specification. So in the documentation, yeah, we'll set up this cluster and parallelly Kubernetes specifications. Okay. So first, if I have to run OpenMRS as a pod, okay, we will not be using it as a pod, but if you have to write a pod, then how will I run it? Then I'll go to the replication controller. Then actually I'll write a deployment spec, and in reality we'll be using a deployment, not really pod or not really a replication spec. So pod specification for OpenMRS core. Okay. Now are you looking at this? What is that we are supposed to tell? We are supposed to tell that we are using some port. Okay. So apart from that, there is nothing over here. You have to tell what is your image. Okay. So shall we write a pod specification for that? So what I'll do is I'll go over here, create a new folder. Let me call it as K8s. And in that K8s, I'll be creating a new file which I'll be calling it as pod.yaml. Okay. So to write this pod.yaml, generally I'll put 3 hyphens because in the future, if I want to write something more, I can use it in the same file. Okay. Now, how will I write specifications? Okay. Kubernetes API reference. I'll go to the API reference. I'll launch this. Okay. So in this, what is it I am supposed to write first? Okay, let this page be loaded and loading be complete. ఒకసారి నాని పిలవండి. ఏ నెట్వర్క్ ఇచ్చారు నాకు? Okay. So if you look at this pod, look at these fields. So I'll start with my field, which is API version, and value of that is v1, that is present over here. Okay. And kind is pod. And then I have to write metadata. Okay. To write metadata, the structure of metadata is defined over in here in this link. Okay. It's fine. While we write metadata, let me also write spec. If I fill all of these 4 fields with whatever necessary information which it is, I'll be able to write a pod for the OpenMRS. Right. So is this open? Yes. Now if you scroll down, there are many things. It is trying to tell, do you have any annotations? Do you want to use any specific cluster name? No, I do not write it, because this should work in any cluster. If I want to make it work on a specific cluster, then I would have used this name. Creation timestamp, do you want to change any timestamp value? No. What is generated name? I don't want to use generated names. Are you seeing labels? Yes. And then if you see, if you want to know more about labels, he has given you a hyperlink over here. You can open that hyperlink. Okay. But let us write labels. But before labels, it makes more sense for us to write name. So spec name, and let me call it as OpenMRS core. Okay. And now if I want to give labels, I'll be writing it as labels. ఏంటి? Oh, yes. ఇదైతే అయిపోయిందిగా. Yeah. Right. So labels, and labels are key value pairs. Right. So if you get into labels, you will try to tell that these are your labels. Whenever you are writing labels, you can write a labels like this. Label syntax looks something like this. Okay. So I am giving a labels, which I'll call it as app is OpenMRS code, and version is 2.4.0. That's it. Now I have to write specification. So for specification, if you see, the information is pod spec. So I'll open this pod spec. Okay, then you have some other fields in the spec also. Which cluster do you want to run? Which namespace do you want to run? Generally, you will not put it unless you have very restrictive environment where you are writing this pod only for a specific cluster on a specific namespace. Generally, will not write cluster and namespace in the pod specifications. Right. So over here, it is trying to tell that what is your affinity, what are your containers. I think this looks like an important thing, right? What are the containers that you want to run inside the pod? Okay. So in containers, he is trying to tell that it is a container array. So whenever you see a term called as array, in YAML we started with hyphen. And each container is defined from here. Yeah. Okay. No, it has to load still. This will test your patience. This page will take time to set back to its own page, right? Whenever you are doing the work, also wait till this whole progress is completed. Then it will navigate to you. Otherwise, you have to search in this, right? Okay. Fine. ఎవరైతే సొంతంగా చేద్దాం అనుకున్నారో కొద్దిసేపు ఆపేయండి, మీకు తెమలది ఇప్పుడు, రైట్? With whatever pace which I am doing right now, if you have done it already once in your home, you can do it. Otherwise, it will be difficult. So if you are practicing it along with me, stop it for some time. Still, I write specs. After that, you can basically do it. Okay, right. So in containers, if you see, there are many things over here. So in containers, what is it I can give? I can give what is the name of my container if I wanted to, right? So, and then come down. Arguments. Do I need to pass any arguments? What are arguments? So while writing your Docker command, if you put something like Docker run or container run, okay, Alpine, sleep 1 day. That sleep 1 day is arguments. Okay. Now look at the command where we were trying to run OpenMRS. Is there any need for arguments? No. All right. So environmental variables. Do I need to set any environmental variables? If the answer is yes, then we have to do it. But for OpenMRS, I don't have any environmental variables. I have environmental variables for MySQL. Okay. For this, I don't have any environmental variables. Right. So then image name. Do I need to tell what is the image name which it should worry about? Yes. Image name. So I'll put, okay, image, okay. And what is the value of image name? Image name is a string. That means that I can directly write my image, which is OpenMRS-core colon 2.4.4. Am I clear on this? So if you want to give a name to your container, you can give. You can call the name of the container as OpenMRS core or whatever name which you want to give. I am giving the same name. All right. Fine. Is there anything else? Okay, ports. Do I need to expose the ports? Yes. Okay. So here ports. And now if you see ports is also an array. So array means you will be starting with an hyphen. Okay. And each port will have an information which belongs to something like this. Okay. ఇది నేను మీకు ఆల్రెడీ చేయమని చెప్పిన పని. నేను కొత్తగా చేస్తున్న పని ఏం కాదు ఇది. రైట్. కొత్తగా చేసేది ఇలాగే చేసి we might be writing a replication controller. That might be a new work. But following this documentation is something which I have shown in the classroom and I'm just filling my command into that. Right. Yeah. Okay. Now container port. So over here is trying to tell what is it you want to set. Do you want to set the container port? Do you want to set host IP? Do you want to set host port? Do you want to give a name? Do you want to give a protocol? I'll be setting a container port. Okay. So I'll be trying to tell that my container port, which I am exposing is 88. Okay. So if you want, you can put a protocol. It is not necessary because by default it is a TCP protocol itself. Protocol is TCP. Done. So this is my pod specification. This is my pod specification for OpenMRS. Okay. So shall I write a pod specification for MySQL now? Okay. So MySQL hyphen pod.yaml. So let me copy most of the information. Okay. So kind is pod. Name is app is DB. We are trying to run a database. Okay. And the version of that is 5.6. You can put any labels, man. Labels do not basically matter. Right. Okay. Fine. And what else? So over here, the name of this is MySQL. My image name is not MySQL colon 5.6. Port is not this, port is 3306. And I have to pass environmental variables. Okay. And now, if you get into this, are you seeing env? Env is env var array. So wherever you see an array, then env. Okay. And then let us see what is env array. How does it look like? Okay. So you have to give name. What is the name of the environmental variable and what is the value of the environmental variable. And now name. Go back to this documentation. What is that we are running? First environmental variable's name is MySQL underscore root underscore password value. For this, I think I have given password. Okay. And next environmental variable name. What is that I have given over here? MySQL database value. Okay. Open MRS. Next, and we have 4 environmental variables. That's where I'm trying to write this. Okay. Name MySQL underscore user value is, I think I've given it as direct DevOps hyphen name equal to MySQL underscore password value. I have written it as that's it, done. This is your MySQL pod. Am I clear on this? So we have a MySQL pod specification now, and we have a OpenMRS pod specification. The reason why I have done this is, right, whenever you are creating a replication controller, whenever you are creating a deployment specification, right, in that you have to tell what is your pod information. And the better way about telling a pod specification is, even though you are not using it directly, try to write a pod specification so that you will come to know what are the particulars which you want to run. And to write a pod specification, if you know how to run your container, you can write a pod specification. If you know how to run your container, if you know basically what are the different commands which you use to start your container, I am exactly using that. This is equivalent to whatever you have written in Docker, container, run, and all of that stuff. You have seen I have tried to fit the same thing. You have seen I have tried to fit the same thing. Am I clear on this? Right? Okay. Now let us see what is the statement. We are messed up now. Okay. ఎందుకు ఫెయిల్ అయింది ఇది? Is it law? Okay, fine. Let me try one more time. ls-a. Okay, right. Now let me upload a file just for the sake of it to see whether it is working or not. Yeah, things seems to be working. Okay, because if you don't have the storage, right, it will not be able to do anything. Okay, fine. Now, shall I set up the Kubernetes cluster? It will take time. So we will execute this. Okay. We have written pod specifications, 2 pod specifications, if you remember, right? So shall I'm directly copy pasting the pod, but I want you to understand the effort that goes into writing this. This is not difficult, but it takes time, right? So pod specification for MySQL. Okay. So for example, if you have 10 pods which you need to run in your application, initially please begin by writing a pod specification, because you'll come to know how your individual pod looks like, and that is very important. Okay. We might not use this in Kubernetes directly, but it is always a better idea to write it, because most of these things will be reused. Most of these things will be reused. Okay. Right. So now let us go over here and go to the Microsoft documentation. See what he's asking us to say. He's asking us to create a resource group, and I'll blindly copy paste this because it will work straight away. Okay. Sorry. Language. For you should see copy. Now language ఎందుకు మారిపోయింది? Whatever. Okay. So okay, and after that create an AKS cluster. See how it is, how much easy it is to create a Kubernetes on the cloud. Okay, let me elaborate this command. Okay, before executing it. Word wrap only. Yeah. Okay. So he's trying to let Azure create a Kubernetes in a resource group, whatever we have called it as my resource group. And name of my Kubernetes will be my AKS cluster. Okay. In that, I want node count to be 1. So you are trying to tell that this is a Kubernetes cluster with 1 node. Okay. So if you want, you can change this 1 to 10 also, 100 also. That's it. Is there not smoke? But from there it is coming in. Okay. So let us assume this is what you said. So now what happens? You are trying to tell that I am running this Kubernetes cluster with 3 nodes. With 3 nodes. And enable add-ons. He's trying to tell that generally we need to monitor a Kubernetes cluster. Now here you are trying to tell that I will be monitoring the Kubernetes cluster by using Azure's infrastructure itself. That is what he's trying to tell that enable add-ons. And now from the same command line, I should be able to work with Kubernetes kubectl commands. So for that kubectl commands, he's asking, say, trying to tell that okay, generate SSH keys so that kubectl can log in. Generate SSH key so that kubectl can log in. Now you go copy this command, run it over here. That's it. Now you tell me what is simple, using this or SSH keys and have been generated on SSH to allow if you are using this with a permanent storage like. Okay, fine. Okay, so basically remember kubeadmin. So we had to do whole circus to do all of this. Now what is it I'm trying to do? I'm executing one command and I'm getting a Kubernetes cluster. Yes. Man, I said right, there is something faulty about this. Our resource group delete ayatnavaki daidram podu. Because there is something that is locked in here. Okay. If it is not working now, I'll take someone else's Azure account. Yeah. Because till it is deleted, I cannot work. Basically, what is happening is when we use that CLI, it needs some storage space. And right now it is unable to create it. So if it doesn't have a storage, where will it set up the whole stuff? Okay. Okay, on my resource. Okay, good. Let me delete all the unnecessary things. This is a cleanup activity, man. It is unnecessarily killing time. మణికంఠ గారు నిన్న మీరు నేను చెప్పింది చేసేసి ఉంటే మనకి ఈ పాటి కుబర్నెటిస్ అజూర్ లో అయిపోతుంది. Okay, just couple of minutes will do this. The point is, I want to just run that Kubernetes cluster and then move because it will take 20 odd minutes for 10 to 20 minutes for the whole cluster to be up. Okay, that's the reason. Let's source code. Okay, so resource groups. You have to wait till these two are deleted. Baboy, ఇది పని చేయదు. This will not work because here OTP is set up and I don't have that phone. Let us try. That's it. I said right. You need a OTP, and that device is not with me. That this is specifically designed for that organizational purposes. Okay. There is no other way, man. I've tried all the routes. You have to just wait till this is done. Okay. It looks like it is done. Let us get started. So create storage. Hopefully, if you are not getting error anytime this time, it is all set. జగదీష్ మీ అకౌంట్ వచ్చింది ఒకసారి వచ్చి లాగిన్ అవ్వండి. మీరు క్రియేట్ చేస్తారా ఇది క్లస్టర్ మీ అకౌంట్ లో ఉందా? ఐఎమ్ యూజింగ్ a different account. Let us not waste time. Yeah. I have one more account, but as I said, that for that there is a set two-factor authentication, and I don't have the second mobile with me. Right. User okay. At the rate. Last at the rate of sir. Thank you. Now, let us see what is that I have in here. Okay. Fine. Kubernetes master setup chesara. This was Kubeadmin, is it? ఏమి లేదు అందులో. ఓకే. Good. Fine. Let me go to the Cloud Shell. Okay. Here, I'll be using a bash. I'm not interested in PowerShell. I'm interested in a bash. So I'm connected to the bash. Right. And then let us get into the documentation over here. First, let us create a resource group. Okay. So is it done? Next, create an AKS cluster. Okay. So let it have a node count as one itself. At least let us see whether it will start first or not. We'll wait for 2 minutes. If it is not failing, it will not fail. Okay. After 2 minutes, we'll go out for a break, come back. By the time we come in, this cluster will be set up. Okay then. So let us go out for a break. Come back. The things are good there. So as long as you don't get an error till this point, it will be okay. Right? Okay. Fine. Instead of kubeadmin, Kubernetes. Yes, we are directly using a finished product of Kubernetes, not the kubeadmin over here. Right? Okay then. So we'll go out for a break and come. Okay, our Kubernetes cluster is up, right? So if you get into resources,
చెప్పండి క్లాస్ అటెండ్ అయినట్టు రికార్డింగ్ కూడా అంటాం కదా మీకు కమ్యూనికేషన్ కాదు క్లాస్ సెండ్ చేయమంటారు క్లాస్ అన్ని ఈక్విటీ పంపిస్తాం సరే ఆన్లైన్ వరకు ఈక్విటీ
Okay. So if you basically look into this, so this is your Kubernetes cluster. So in this cluster, are you seeing scale? So if you look into this and if you want to increase number of nodes, remember you are credited with one node. Yeah. If I want, I can increase this basical value, right? Or I can go with node pools. And then are you seeing upgrade? Okay. So if I want to move Kubernetes to the latest version of Kubernetes, I can basically select this and then say apply. All right. And this application will be done while your upgrade of Kubernetes will be done while your applications are running, not by stopping the application. So this is not a downtime activity. Right. Okay. So we have done this. This is what we have run. Okay. And then we need to install CLI. This CLI is all about installing kubectl. So copy this command, get into the Cloud Shell. Man. ఏంటండి ఇది మీరు గ్లోబల్ అడ్మినిస్ట్రేటర్ కాదా? ఏంటండి ఇది ఎలా ఇబ్బంది పెడుతుంది వాళ్ళు? Man, I don't want to create a Linux machine now and then do all of this. Right. Okay, let me see. Okay, we have kubectl, fine. Let me try this, whether it will work or not. Okay. Now, remember from here it is same. Kubectl get nodes. If you are getting an answer of this as one node for whatever we have basically created, it is all set. Are we seeing nodes? So from here it is the same. Kubectl get pods. So right now I will not have any. Okay. But if you want to see pods across all the namespaces, then you can give pods all namespaces. So are you seeing everything is set up? Okay. Remember while we have installed kubeadmin, we have used a CNI plugin which was called as ViewNet. Yeah. Over here an Azure CNI plugin will be installed. The pods which are created in this network will be directly available on Azure's virtual network. Okay. In the case of Amazon, they will be available only directly on Amazon's VPC. That's how this basic stuff works. Right. Okay. Now we have everything. Okay. So I have the Kubernetes cluster. If I want, I can scale the cluster by telling how many nodes do I want. What is the version of the Kubernetes nodes, Kubernetes cluster, which I'm basically executing. So my cluster is set up. Okay. Let us go back to this. Okay. I have 2 pods. Okay. But pods are not enough because running a pod will ensure your application is running. But if it goes down, it will not really help because the desired state over here is just container is running or not. To do that, what is that we'll write? We'll write I'll be writing just replication controller, but I'll be using deployment as I said. This is something which I'm writing just for our understanding. Okay. Go back to the API reference. In API reference, are you seeing replication controller? Yes, I'll select replication controller. And in replication controller, what is your API version? V1. And here the core, it is core. Ideally, it is core slash v1, but if it is core, there is no need for you to write core slash. Okay. So API version v1. And then what is the next value? Kind. Kind is replication controller. And then we have metadata. After metadata, we'll have spec. This is same for every Kubernetes object. But what goes into metadata and what goes into spec will basically change. So in the metadata, if you open this metadata, it will be the same thing. Let me go and click on metadata, and let me also open replication controllers spec. Wait till the page is reloaded and it goes to the replication controllers point. Yeah. Okay. Right. It will be redirected to wherever you want. So metadata, and in metadata you will have exactly the same fields. Right. So let us start with something called as name. What is the name of it? Open MRS hyphen RC. RC is replication controller, right? And then basically scroll down over here, okay? And then if you want to give in a specific, if you want to give specific labels to this, if you want to run it in a specific environment, okay, you can do all of that. So let me go ahead and give labels, and I'll be using a label which is app is open MRS and version is 2.4. Right? And now let me come back to specification. The specification I opened in this page. Okay. So in this specification, what is it trying to tell? How many replicas do you want? Okay. I want 3 replicas or replicas or whatever it is. You will basically set that. Okay. Right. And then are you seeing selector? Okay. So we have to write a selector. Selector will tell what are the labels which your replication controller should be worrying about. My replication controller should worry about, okay, labels which are called as, these are your pods labels. Okay, remember in pod.yaml, what is that we have written? What is our labels name? OpenMRS, core, and then version is 2.4.0. Okay, so these labels are replication controllers labels. And these are the labels which replication controller will try to tell to, will try to check basically. Okay, fine. And then are you seeing something called as template over here? Okay, let me go ahead and write something called as template. And in template, what is it trying to tell? Template structure is pod template spec. And if you understand correctly, we have written pod template specification already over here. All of this was pod template specification. This is what we have written in a pod. Okay, right. So let it open in the pods template. Okay, let us wait till it goes to that point. Okay, so are you saying pod template spec? Okay, and pod template spec says that you have 2 things in here, metadata and spec. So where is RC? So here you will be writing metadata. In metadata you will tell I have labels. In labels you will tell I have app, which is OpenMRS core. These are labels of your pod. Okay, and then version is 2.4.0, and then you are writing spec. So metadata and spec. Over here you write pod spec. So if you get into pod spec, let us open that pod spec also. In the pod spec, you will try to tell what is the what is the pod that goes into your replication controller, right? If you follow that way of basically looking into it, it is something. Even if the template structure changes, we are really not impacted with this. Okay. So over here, what is that you are trying to look out for? Okay. I will be trying to tell that my images slash open MRS core. Okay, was this the image name? Open MRS hyphen core. Okay. Open MRS hyphen core slash 2.4.0. That is my image's name. Okay. And then what else do I want? I think I should be worrying about ports also, right? Yes or no? Yes. Okay. So if you see, this is a pod specification. Okay. Oh. Spec lo undedi containers kada. Containers, and within containers, you will have 2 containers. And if you understand it correctly, this is nothing but this area. Okay. You are exactly writing the same thing over here. Okay. So let me go over here. So that's it. So what you are trying to tell that it is, this is a replication controller. In here, I'll be running 3 replicas. Okay. I'll be trying to run a selector. Selector will tell what is your pod, what are your pods labels. My pods labels are, there will be something called as open MRS core. It will have a label called as 2.4.0. And then you're writing a pod template. In pod template, you will tell what is the metadata of your pod. My pod will have these labels. Okay. And then here you have to give the name also. What is the name of your pod? Name of my pod is open MRS core, or you can give open MRS pod, whatever that makes sense to you, right? So you can give this, or you can skip this. That is your choice. Let it fail if it fails. Okay. Now here you will have a specification. You have a labels, right? And then you have metadata and you have a spec. Spec should be and metadata should be here. Okay. Now this is right. Yeah. Because in pod template, we have 2 things, metadata and spec, and they both should start at the same position. That is what I've done. Okay. That's it. This is your replication controller. But what will replication controller do? It will just run number of pods. Tomorrow, if you are running a daemon set, then what will you do? If someone asks you to run a daemon set, you will go to the Kubernetes documentation. You will see where the daemon set is. If you click on daemon set, you will get a daemon sets example. Over here, it says that API version is apps. If you see core, there is no need for you to write it. But if you see apps, you have to write apps slash v1. Okay. Look at an example of this. Apps slash v1. Core if the name over here is core, then there is no need for you to mention about a group, because core is a default group. If you are seeing any other name apart from core, okay, then you have to give the full name, apps slash v1, and then get started. Over here, API version, app slash v1, kind, okay, daemon set, metadata. You will open that metadata section and you will fill the values. And then spec, daemon set spec. Daemon set spec will have its own values. Now, if I am writing a deployment story, see. So I'll go to the deployment. Okay. And when I am writing a deployment, I'll basically look at what is it. So deployment comes with apps. So I have to mention apps. So shall I write a deployment now? Yes. In reality, what is that you will be using? You'll be using deployment, not replication controller, not pod. You'll be writing a deployment. Deployment is one file is enough. Okay, you'll be writing 2 things in Kubernetes. One is deployment, the other one is service. Deployment and service. Right? So I'll be trying to tell that open MRS hyphen deploy. This is what I'll be using. Okay. So I'll be starting by saying API version. And what will be the API version of the deployment? Apps slash v1 apps slash v1. Okay. I have shown you all the other stuff because to understand how to write it. But in reality, it is required for you to write only two things: deployment and a service. Service so that your application is exposed to the outside world. Deployment in such a way that if something goes wrong, you can go to the new version, you can come back to the older version, you can do all of that stuff, right? Okay. Now over here I have to write kind, and my kind is deployment. See, even if you write a deployment with D in a small case, it will fail. Here it is a case sensitive approach, right? So you cannot change the casings. Deployment and small d to rise in deployment and ఒకటే అని మనం అనుకోవచ్చు కానీ Kubernetes కదా ఒకటే కాదు. For Kubernetes they are different things. You have to follow the same casing also, right? And then we have metadata. In metadata I'll be writing something called as name, and name is openmrs hyphen deploy. Am I clear on this? Okay. Right. So, and then I have to write something called as spec. Now the spec is deployment spec. When we were writing a replication, we had a replication controller spec. When we are writing a daemon set, we have a daemon set spec. When we are writing a pod, we'll have a pod spec. So whatever you are writing, you'll have that specification. All right. So spec. Now let us see what is there in the spec. Okay, so it says that how many minimum ready seconds. Okay, let me start with that. Min ready seconds. Okay, try to read this. Minimum number of seconds for which a newly created pod should be ready without any container caching for it to be available. Okay, so after your pod is created, how much time will it take to become ready? Okay, for sometimes your applications, let us assume it might take some time to start. So let me put it as 10. That means that your application will be ready in 10 seconds. If your application takes 1 minute, then try to write 60 seconds over. Okay, till it will try to check whether your application is running or not. Okay, depending on this number. Okay, so fine. And then paused. No, our application is not paused. If you want to set it to be a paused state, then you can do this. Okay. Progresses, we don't want it. Replicas. How many replicas do you want? I want 3. Right. I want my OpenMRS to be running at 3 different places. Or if you want to run it only as 1, you can tell 1. Let us put it as 1, then we'll change it. Okay. Fine. And then, are you seeing selector? Label selector for pods. Okay. This you will write whenever you want to use existing replica sets. This will use whenever you write existing replica sets. You can do that. Okay. So I'll write selector, and then when I'm writing a selector, I can tell that okay, label selector for pods. Existing replica sets whose pods are selected by this one will be affected by this deployment pods template. And if you want to write this, you will try to tell how to write a label selector. Since it is an object, you start with 2 positions. Okay. If it is an array, you will basically put a 2 positions, and then after that you will write a hyphen over here. But right now it is not an array, it is an object. Okay. Let this page be loaded. Okay, right. So label selector, scroll down. He's trying to tell match expression or match labels. So for example, if you want to tell that I want to create a deployment for all the pods where there is a label, okay, which has app and which has any values like OpenMRS, or if you want to give that expression, right? So whether it contains, doesn't contain, matches, regular expression based matching, then you will be basically going with expressions. Or else you can write something called as match labels. And in match labels, is trying to tell that match labels is an object. Okay, you can write key value pairs. Okay, you can write simply a key value pairs, right? So in match labels, you can tell that okay, match any labels where there is something like app, okay, and OpenMRS 4. So now what I'm trying to tell with this is match any pods which are running, which have a label which is called as app is OpenMRS core, and Version is 2.4.6. Okay, this is a selector. Okay, right. So you have done with your selector, and then strategy. Okay. So remember, I was being asked about canary deployment. Okay. So whenever we are deploying our applications, we do deployment in such a way that our application is not impacted. So whenever you are doing deployment, what you will do is you will not apply the deployment to all of your machines at one shot, all of your pods at one shot. So what you do is first you will increase one machine for increase certain number of machines. Okay. So let us assume you have 3 pods. Okay. What you will do is you will add a 4th pod. In that 4th pod, you will have a new version. Once that new version is up, you will delete the older version, right? So then you will basically go, you don't deploy everything at one shot. So for that, what it is trying to tell is you can define something called as a strategy. In that strategy, tell that what is the stuff. Do you want to do rolling update or do you want to do recreate? Recreate means stop everything and do the deployment. That is a downtime based stuff. We will never do that. We will basically go with a rolling update. Okay. So, and now selector, and then we have strategy. In strategy, we'll have rolling update. I think you will be capital over here. Okay. Yes. And type is recreate or rolling update. Default is rolling update. So if you write the type or if you don't write the type, it is the same thing. Type is rolling update. Okay, this means that it will do in parts. It will not do the whole stuff at one shot. Okay, so whenever you are doing a rolling update, it says that for doing rolling update, I have a structure. Click on the structure. And here you will have 2 important values. Let us see what those 2 important values are. Okay, good. Wow. Okay, are you saying max search and max unavailable? Max search is maximum number of pods that you can go beyond your limit. That means that I have 3 pods already running. You have said replicas are 3. So how many new pods can I create with a new version? Okay, so it says the default number is 25%. Default number is 25%. You cannot set to 0. You can set any value between 0 to 100 in terms of percentage, or you can directly give the number. You can directly give the number. So I might tell that strategy is rolling update, and in this, okay, what is the first thing? Max search. So max search, let me call it as 35%. Then let us assume that you have 10 pods. It will, what is the 35% of 10? 3.5. It will round it to the nearest integer, and then it will do the deployments in that stuff. Okay. So, and then what is it trying to tell us? Maximum number of pods that can be unavailable during the update. So while you are doing upgrades, okay, so whenever you are doing the upgrade, your older version will die at some point. So how many of that do you want? So if you say 10%, then you will have 10 deployments that will basically go. But if you say 25%, it will have 25% of the stuff will go down at that moment. So I'll just say max unavailable equals to 30 or 30%. So what I am trying to tell is, if my application has 100 containers, I am okay, 100 pods, I am okay if the 30 are not working. If my application at a bare minimum runs with 70 pods, I am okay with it. Okay, that's what it means when I say 30%. So is it done? Okay, so from this strategy, you will tell what your canary deployments model is. Canary deployment goes in this way. Whenever you are doing a deployment, you will not apply it to all the machines. You will do it in smaller portions. Okay, whether you want to do 10% at a time, whether you want to do 15% at a time, whether you want to do 30% at a time, or whether you want to do 5% at a time. That is what the basic step. So if you make your max unavailable to be 5%, then only 5% of the older versions should be unavailable. Rest of the things should be available. So it will try to do it in 5% basis. So, but if you have only one node that is running or one pod that is running, it doesn't make sense, right? But if you have plural number of pods, then this strategy will come into play. నేను ఒక్క పాడుతోనే రన్ చేస్తాను, డిప్లాయ్మెంట్ చేయొచ్చా? చేసినా పెద్ద ఉపయోగమే ఉండదు, right? Because you have only one machine and that machine has to go down at some point. That's the whole point, right? Okay, fine. So we have written strategy. So is the strategy done now? Where is that? Okay. Is the strategy done? And now what is he trying to write? He's asking us to write a template. And this template is a pod template specification. So template. And if you remember pod template specification, we have already written in the template of this. This was our pod template specification. Yes or no? So I'll basically go over here. Copy this. Done. So this is my deployment. This is my deployment. I'm trying to tell that. Okay, let me put it as 3. I want to run 3 replication controllers or 3 replicas of my pod, and my pod will have the following labels. And when you run this, right, you will get errors. Okay, there is no doubt that you will get errors, because many of the times what you might end up doing is you might mess with syntax. Okay, so for example, in the strategy, if I write rolling update like this, it is an error, because strategy has a rolling update. That means that you have to give 2 spaces. Okay. First thing, who are not good with YAML, you might mess up at here. Second thing is, generally there will be certain times you might write some extra fields which are not necessary. Sometimes you might not write the minimum number of fields. So you might get that error also, right? So it's okay. Right. So let me copy the path of it. Remember our Azure. Reconnect. Are you seeing upload file here? So let me click on upload. Okay. And let me try to write a file over here. Are you seeing kubectl openmrs.deploy? Yes. Now if I say kubectl apply -f openmrs deploy. Okay. Let me make this a full screen, because this is what we are working on right now. Okay. Let us see what happens. Oh. For me, it says the deployment is created. So when you create a deployment, kubectl get deployments. So it says that right now we have asked for this state. Okay. All right. Sorry, Singh. We said that 3. Remember, we have said min ready seconds equal to 10 seconds. So it will not tell your pod is ready till 10 seconds are finished. Till that time, it will not measure. That's where you are seeing that delay. By default, the value of that is 0. If you put that the value of it is 0, then it will try to check it immediately. Okay. Right. So what was the deployment? Deployment is internally, it will create something called as replica sets. So kubectl get rs replica set. Let us see what happens. Right? And then let it be anything. What it will create, eventually it will create. So are you seeing all the 3 pods? Yes. Okay. Now if you see the state of our application, we have a pods that are basically available. But can I access that pods from the outside world? Yes or no? Okay. Kubectl get pods -o void. If you see, I have pods have IP addresses. But can I access this from outside world? No. So for that, what is that I am supposed to do? Remember service? So we are supposed to write a service. So now, where is our documentation? Okay. Now we have written till pod, right? Replication controller for OpenMRS will look like right rc.yaml. Okay. Deployment of the Open MRS will look like this. Okay. So, right. Fine. So, do I have deployments also now? Is it deployment కాదు కదా? Deployment లో కూడా replication controller కాపీ చేసినట్టు. Yeah. Right. Open MRS deploy. Okay. Right. But what is that we need to write now? We need to expose this service to the outside world. But before we expose this service to the outside world, don't we require a MySQL also? Yeah. So shall we do a MySQL deployment? Yeah. So deployment for MySQL. So I'll be basically going over here, new file, MySQL hyphen deployment dot YAML. Okay. So what I'll do is I'll copy paste and make the changes. Is that okay? Yeah. So name is apps1. This will be MySQL hyphen deploy. Spec min ready seconds is equal to replicas. I just need one replica. I don't need three. Okay. And the selector app is MySQL. I don't need two labels also. And to be very specific, I'll not have a strategy. Let it go with the default strategy. Okay. Template metadata app is MySQL. As I said, I'll have only one label. And container name is MySQL and images MySQL colon 5.6 and here the port is. But here we have one more problem. This needs to remember the data. In the earlier case, we had a benefit because our OpenMRS doesn't need to remember anything. But in MySQL, all of your data is being stored. Whenever your data is getting stored, then if you remember, we have to worry about persistent volumes. Okay. So ideally in persistent volumes, there are two ways of doing it. One is you create a persistent volume and then you create a claim. And then you create a claim. And if you remember, I have said that in Azure or in AWS, there is no need for you to basically go with a static provisioning. You will have something called as dynamic provisioning. All right. So what I'll do is, okay, where is my stuff? Okay. No. So here he speaks about storage. Okay. So let me show you something interesting. Okay, sorry. In Azure, if you basically say kubectl SC is storage class. There are already two storage classes that are available for you. Default means it will create a default Azure disk. Manage the premium means it will create a premium disk for you. Now, I have a storage class which already knows how to create a disk in Azure. Now, the only thing which I need to worry about is how do I create a persistent volume claim and use this disk. Are you seeing there are two names here? Default and managed premium. Default knows how to create a default disk. Managed premium knows how to create a premium disk in Azure. దీనికి ఆల్రెడీ డిస్క్ ఎలా క్రియేట్ చేయాలో తెలుసు. Remember, we have a static provisioning and we have a dynamic provisioning. In dynamic provisioning, provisioner will know how to create disks. So that is what is already mentioned over here. Right? So now let me go to storage. Where is, are you seeing somewhere storage here? Yeah. So I think Azure disk dynamic and Azure disk static. Yeah, I'll give a link of this. Okay, Azure Disk Dynamic speaks about dynamic provision, right? Azure Disk Static speaks about create a persistent volume. After you create a persistent volume, write a persistent volume claim and then try to do it. So let me go with dynamic provisioning because that is what whole world is using at this moment. Okay, so మనది ఈ లాంగ్వేజ్ ఎందుకు మారిపోయింది నాకు అది అర్థం లేదు, అంతా బానే ఉంది కానీ. I'm not sure, man. Oh, I got it. Here it is. En slash. Yes. Okay, right. Okay. So, are you saying Kubernetes is trying to tell that there are already dynamic provisioners available? So, while writing MySQL, we need to persist data. In the case of Azure, refer here. See, remember whenever you are doing this activity on AWS, this persistent volume claim might change because it depends on in which environment actually you are creating it. Disk ki environment to sambandham untundi, right? Whenever you are trying to deploy MySQL into Azure, you might be using Azure storage classes. Whenever you are doing it on Google, you might be using Google storage classes. Whenever you are doing it on AWS, you will be using AWS storage classes because these storage classes know how to create hard disks on the particular cloud. So if you are doing it in your company, then you don't have any chance. Are you looking at that persistent volume static way? Go and create a disk. Okay, and that disk, make it available to all the nodes, and then you write a persistent volume. First create a persistent volume, attach it to your Kubernetes cluster, and then basically try to create a claim. Static ga chesinappudu aa talanepanta manam padalsinde. But if you go to the dynamic provisioning in the cloud world, you have to know what are the storage classes that are supported, and you can directly use it. Okay, so since it is Azure, I am using Azure storage classes right now. If I am using AWS, I'll be using AWS supported storage classes. Right. Now, if you go through this example, he's trying to tell that if you really want to use it, just go and create this. Are you seeing this? He's creating a persistent volume claim. And after he creates that persistent volume claim, what he does is he attaches that claim to your specification of the pod. Okay. Then you will get a volume. But what is that you need to do with a volume? You need to mount it onto your container. So just look at the flow. Here he has created a persistent volume claim. So let me go ahead and create that one first. So where is my pod? So I write one file because I can put everything on over. So and here he is trying to tell that the storage disk is 5 GB. And then here I'll put it as, remember you have two storage classes and you can use anything. Okay. And over here, read write once. Here you will have two options. Read write once, read write many. Okay. Read once, read many, write once. Okay. What does it mean is you have a disk and whenever multiple pods are using it, how do you want the access to be set? Do you want a read only access to all the pods? Do you want the pods to write it? Whenever pods are writing it, do you want all the pods to write it or do you want only one pod to write it? Okay. And other pods you have to wait till that write is finished. So you are giving that read write controls to your volume. So right now we have only one pod. There is no need for us to even worry about it. So we will be using read write once. Am I clear on this? Yeah. So what is the disk which I am trying to create? I am creating a disk with 1 GB. Okay. And if you remember, I am not creating a persistent volume here. I am directly creating a claim. Since here there is a storage class which knows how to create a disk, it will go and create a disk. Otherwise, if I am using a static, I have to create a disk in Azure first, and then that disk I have to attach it to the Kubernetes cluster, and then for that I have to create a persistent volume, and then I have to make a claim. But if you go with the dynamic provisioning, it is much simpler, right? Okay. So I have a persistent volume claim. Then see what he's trying to do. Okay. In your pod spec, okay, he's trying to write something called as volumes. So is this my pod spec? Yes. In pod spec, you have containers, right? So similarly, you'll be writing something called as volumes. And in this volumes, he is trying to tell what is your claim. Because remember, who makes a claim? Pod makes a claim. When pod makes a claim, Kubernetes will check whether there are any disks with that. Okay. If they are available, they will give it to the pod. So pod got a volume now. And after you got a volume, what is that you are supposed to do? You are supposed to mount that volume into your Docker container. And if you remember in MySQL, we have seen that where lib MySQL was a volume of MySQL. If you remember the Docker file which I have shown, in that there was a volume in Docker which was called as where lib and MySQL. So whatever disk which we are getting over here, we'll mount it onto the where lib and MySQL. So let us do this. Volumes. Let me give it as hyphen name and let me call it as MySQL volume, and then let me use the same thing, persistent volume. We are using the same claim name, right? Yeah. Persistent volume claim. Okay, two spaces. Is it two? Right. Persistent volume claim Azure managed disk. Now what happens? Azure managed disk means this is what Azure managed disk is all about, because you have given the claim name as Azure managed disk. If you want, you can change the name. You can call it as MySQL hyphen disk. Okay. మనం ఎలాగో చేసింది కాపీ పేస్ట్, మళ్ళీ దాన్ని కప్పించుకోవాల్సిన అవసరం ఉంది. Right. It's okay. Fine. Now what happens? When this is successful, you will get a volume. You will get a Kubernetes volume. This Kubernetes volume, we have to attach it to your Docker container. Remember, Docker container run -v. Then we used to tell what was our volume. Now we got a volume. We are supposed to attach it to our container right now. So to do that, okay, if you get into the container spec, remember we have ports over here. Okay. Yes. Like ports, you will have something called as volume mounts. In that volume mounts, you can specify number of volume mounts. Okay. But we have only one volume mount. So I'll be telling mount path is equals to, let me go back to this. Okay, I think this is where I have opened it. What is the volume over here? Where lib and MySQL. Good. Where lib MySQL. Okay. And you have to tell what is the name of it. So that is exactly what you are trying to give. Okay. Name. And here the name should match your persistent volume claims name. What is the persistent volumes claim name? Now what is that you are trying to do? Your pod, you are trying to make a claim. Okay, claim is defined over here. Okay, and then whatever volume which you got out of this claim, you are wanting it onto your Docker on the Docker volume. So how is actually your Docker volume getting a disk? From Kubernetes. And how is Kubernetes getting a disk? From storage class. How is storage class getting a disk? It knows about how to create a disk in Azure. Right? Tomorrow when you are working on AWS, you will be creating a disk in AWS. Right? Okay. Fine. Now we have this, right? So shall we deploy this? Yeah. So where is this? Upload a file. Copy this path. Okay. So kubectl. Okay. Apply -f MySQL. So in this, I am not writing only MySQL deployment. It has a volume claim also. It has a mount also. Right. So, is it done? I am not getting errors, right? How? That's it. I have done this a lot of times. Right? You try to create a pod, you will get a lot of errors. Because that might be a first time. Once it comes with experience, right? So that's it. Fine. So now you do this kubectl get deployments. So we have two deployments. Okay. MySQL is still not available. It will take some time. All right. So get deployments -w. Let us wait till that deployment says that there is some success state. If it is 0 by 1, it will never work. We can do one more thing. kubectl get pods. Okay. Let me do a watch on this. Because once that container creating changes to running state, everything is set. Okay, let it do its job. Okay, fine. Now, if you remember, I have two kinds of pods now. One which is running OpenMRS, the other set which is running a MySQL. Okay. Now, what is the problem now? We are in a state. Okay. Let me first copy this. Deployment for MySQL in Azure. Okay. Now, how to enable communications between pods. Okay. Now the problem is I have MySQL, I have OpenMRS. Okay. Is it guaranteed that MySQL pod will run all the time? No, it might fail. So whenever it fails, a new pod comes up. Whenever a new pod comes up, we get a new IP address. Right? To resolve that, what is that we have learned? We have learned that we can use something called as a service. We can use something called as a service. Okay. Service is a load balancer. Okay. And service has a way to expose it to the outside world itself. But do you want to expose MySQL to the outside world? No. What is that we want to expose it to the outside world? OpenMRS, not really a MySQL, right? So, service for MySQL without external access, right? We don't want to expose it to the outside world. Right. So then it will get only IP address within the cluster. That is called as cluster IP mode. That is called as what? Cluster IP mode. And then we have something called as a load balancer mode. Load balancer mode means it will be connected to a load balancer. If your load balancer is basically publicly exposed, you should be able to get in. Otherwise, you will not be able to get in into that. The third one is node port. The third one is node port. Node port means your service will be exposed on every node on a particular node, on a particular port. So for example, I can say that whenever I am running this application, whatever application that is running behind this service will be exposed on every node of your Kubernetes cluster on a port 8080, on a port 30,000, on a port 30,001. That is the node port. Node port is good for dev environments, not really good for production kind of scenarios, because you might not give an IP address of every node to the outside world, which is not a very good design. Okay. So we have three modes there. What are they? Cluster IP. That means private. It is existing only within your cluster. Then we have something called as node port. What is the purpose of node port? Node port is your service will be exposed to the outside world on a particular port. Remember port forwarding? We do port forwarding, right? So on a particular port on every node of your system, right? And then the third option is load balancer. And since we are in Azure, for MySQL service, I'll be using a cluster IP because I don't want it to be exposed to the outside world. But when it comes to OpenMRS, I'll be exposing it to the outside world. And how will service know what are the pods that are running? Labels. And for every pod, while we are writing pod, did we create labels? So I'll be load balancing using that. So now what is that I should write? I should write a service. So if you come down over here, are you saying service? Yeah. So now the scenario is exactly the same, but let me use the example straight away to save time. Okay. So I'll copy this. Okay. And then I'll basically get into the other stuff. So I'll be creating services dot YAML, and in this I'll be writing two services. First service I'll write it for MySQL. So kindness service. API version is V1. What is the name? Name is MySQL, and I'll call it as SVC. And basically then you have to tell what is the port which you are supposed to access the data. Then you have to tell what are the labels. So what is the label on which our MySQL is running first of all? MySQL has a label which is called as app is. So I'll be writing app is my SQL. Okay. So then type. Okay. So let me get into the service specification. Okay. Let it open that service specification. Then we will basically write our stuff. Okay. So we got our service spec. So here you can give something called as cluster IP, external IP, external name, external traffic. Okay. What is your load balancer IP address and what are your ports? Ports are actually important for us because they try to tell on which port is your application running. So we have written ports. And on the ports, it is an array. So array of service ports. So I've written array name. Okay. And then let us look into this. You have to read through every point and the documentation beside it. Okay. So service spec, a name. So here he has given the name as HTTP. I will not do that. I will call it as MySQL. And then port. The port that will be exposed by this service. Remember, it is the layer 4 load balancing. Okay. And then you have something called as node port. Node port is basically the port on each node that will be exposed when type equal to node port, right? And target port. Target port is number or name of the ports to access on the. So I am not interested in this port, but I'll be writing my port is 3306. Okay. And now over here, port, the port that will be exposed by the service. What is the port that your service will be exposing? So if you want, you can put this one also. You can put this port and you can call this as 3306. So your MySQL will be exposed to the outside world by MySQL's IP address, and it will be working on a port 3306. Okay, fine. Now let us come back to our stuff and then scroll down. Are you seeing type? Type determines what it is, and the default type is cluster IP, and I want to use cluster IP because I don't want to expose MySQL to the outside world. Done? Okay, right. And then whenever you are writing a load balancer, cluster IP, you can go to this documentation. But whenever you are writing a load balancer, go to the Microsoft's documentation. Over here, if you see, we have looked into how-to guides, and are you seeing configure networking? If you get into the configure networking, he will try to speak about how to use a standard load balancer, how to use an internal load balancer. Let me click on how to use a standard load balancer. I want to look at spec. I'm not interested in all of this. Come on. Okay, are you seeing the stuff over here? So he's just trying to tell that I am going to use a load balancer. The port is equal to 80, and basically selector is whatever selector for your application. So now what I'll do is I'll not do all of this. I'll basically copy this. Okay. API. And what is the name of our application? Our application is Open MRS. Okay. Open MRS, na? Yeah, Open MRS SVC. Type is load balancer. And the port will be 8080. Okay. And then remember target port. Target port is a port on which your application is running, which is also 8080. You can give port, that is more than enough because it will be exposed anyway. But it is always a good idea to give a name also. What is the name? Name is Open MRS. And now selector. How do you want to select your Open MRS application? If you remember, in Open MRS application, I have used two labels. App is OpenMRS core and version is 2.4.0. So let me go to the services, and when I'm writing a selector, I'll be writing these two things. So is it done now? So I'm writing a Kubernetes service, one for MySQL, the other one for OpenMRS. And the way I'm trying to basically load balance is I'm trying to tell that this will work in this way. Okay. So shall I try to run this? Okay. Now let me click on upload the file. Algebraic Inesu, right? kubectl. Is it creating? Yeah. So then kubectl get svc. So remember, for accessing OpenMRS, we need this external IP. This external IP address is IP address of your load balancer. So did I got the external IP address? Okay. Now let me see how this will work. Colon 8080 slash okay. Okay, we got 8080. This is an IP address of it. First, let me see if I'm getting Tomcat. Yeah, I'm getting Tomcat. Because this is Tomcat's homepage, it will not work. Slash OpenMRS. Yeah, did I got the page? I'm able to run my application. Yeah, so now in OpenMRS, you can set up MySQL. You can set up a connection with MySQL over here. Let us see. I'm just trying to show you. So, ఇది ఖాళీగా ఉన్నప్పుడు చూసుకోండి, but what I'm trying to do is I'm trying to do the setup. So, for selecting a database, do I need to give database's IP address? So this is a connection string. He's trying to tell that database is in the local host. But is database in the local host? No. So where is my database present? You can give this IP address, or you can give name of your service. I am giving name of my service over here. Okay. So remember, we have given username and password. The username was root and the password was password. While creating a MySQL, if you remember, we have set the environmental variables. Yeah. Then he's trying to tell that, do you have any extra usernames? Remember, we have created a user called as direct DevOps. Direct DevOps. Okay. Then he's asking, do you want to create a web interface? Do you want to just put it, stick it to default values? Okay. So for us, we are just testing whether the database can be connected or not. That's it. Right? Try to set some password over here. Okay, don't put anything. Click on next. So just click on next. Okay. Unable to connect to the database. Fine. All right. I can do one more thing. Let me do one thing. I know why this error is happening. Okay. So what was the deployment file for us? OpenMRS. Deploy, right. Let me set the replications to be 1 and then kubectl apply -f open. Ideally, you should be doing kubectl rollout to deployment. Go to the documentation. I've given the commands. You should be using that, but it's okay. for now. kubectl get. Let us look at pods. Okay. Oh man. మనం 5.7తో రన్ చేసామా? MySQL is crashed. 5.6 ఇచ్చామా 5.7 ఇచ్చామా? 7 has a crash, not 6. kubectl delete -f. What was it? Open MRS కదా. MySQL deployment. There is an issue in 5.6 or 5.7. I am not sure, man. Okay, fine. Let me apply it. Okay. So kubectl get svc. All right. Fine. Now let me try to do this. Okay. Now let me do this. Yeah, there is no need for me to do all of this. Let me do one thing. kubectl get pods. Okay. Can I get inside this pod? Yes. How do I do that? kubectl exec -it /bin /bash. That is something like docker exec -it, same story, right? So let me give ping. And what is the name of my service? MySQL svc. This ping will not work, but at least you will see the IP address of your service. Let us see whether that is happening or not. So are you getting the IP address of the service? 10.0.0, because for ping, your firewall should be open. Now the firewall is disabled. It is not allowing the packets to leak, right? So, good. Now, let me exit out of this. Okay. And then kubectl get pods. We have to wait till it is in running state. Otherwise, we can't do much. I find whatever it is. But was I able to deploy my application, the whole application? Yes. So what does it take? First, you should know how to do it manually. Right? I knew that my application was OpenMRS. It required MySQL to connect. So for that, I have created two different deployments. One for my OpenMRS, the other one for my MySQL. Right? Then I have came up with my Docker commands. Once I have came up with my Docker commands, then what I have done is for the Docker commands, I have started writing Kubernetes specifications. For the Docker commands, I have started writing Kubernetes specifications. And while I was writing a specification, initially I started with the pod specification, then replication controller specification. But if you remember, I have not used any of them. I've used deployment because deployment internally has both. Deployment has a pod specification and also it has how many replicas do you want. Okay. And then on top of replications, what is that I have done is I have created a service. So for the service that has to be open to the outside world, I have given a type as load balancer. And for the service that has to be internal, I have given a type as cluster IP. Am I clear on this? So was I able to do this application? Yes. Now you go back to the yesterday's documentation which I have asked you to go. But direct DevOps.blog. Okay. Over here, scroll down. Click on this. So over here, there is a Python application. And here, what is it I am trying to do? I am trying to clone the project. I am trying to see how to run this application manually. Once I know how to run this application manually, then based out of that, I have built the Docker image. Okay. So once I have the Docker image built, then I have written the commands. So was it not the same thing which you have done today? Yeah, it is an approach which we basically follow. So now I know how to run Flask application and I know how to run a MySQL application. Then it is all about writing specifications. So I'll come down and then, okay, this is how to send, remember we have done Docker push. So if you want to push it to the Amazon's registry, how do you do that? Okay. In Amazon, there is a registry called as ACR. which is a private registry, right? So, and similarly, if you want to push the image to Azure, what is that you would be doing? Okay. So I have written this. So this is something which you can do. And over here in the classroom, what I have done is I have created a AKS cluster. In this documentation, what is present? We have EKS cluster. So what I have done is I have taken a AWS machine, EC2 machine. In that I have installed AWS CLI. Okay. And after that I have installed EKS cluster. Remember, while we were basically preparing the Azure, we have run one simple command in Azure, which created the cluster. This is simple command of Azure AWS, which will create a cluster. And generally, whenever you are giving nodes, right? Okay, try to give less number of nodes. Okay, and T2 micro will not work out. T2 micro will not work out. To test this, you need to spend some stuff. So take a T2 medium. At a max, give 2 nodes. Don't go beyond that. If you want to shell out some money, yeah, you can do that. All right. So, and then remember MySQL storage. In MySQL storage, what is that we have written in Azure? We have written a persistent volume claim. That was enough. But over here in AWS, we have to write because there is no storage class. kubectl get SC. In the case of Azure, we had 2 storage classes. One was the default, the other one was premium, managed premium. In the case of AWS, you have to go and create this. So if you understand this, how many of you know AWS here? So while you are creating a EBS, which is Elastic Block Storage, you have to tell what availability zones they have to belong to, yes or no. That is what he's trying to do. This is nothing but EBS creation. Okay. Now what is the storage class name which you have given over here? GP2. And what he does after he creates it is he is creating a persistent volume claim. Remember in Azure, I have started from this step because there were already storage classes. In the case of AWS, you have to go and create a storage class. And after that, you have written a pod. In the pod, you have used the basic volume mount. So if you go over here, are you saying this stuff? MySQL service and then storage class and then persistent volume claim. Okay. After you have a persistent volume claim, then you have created a deployment of. Oh, we have not given all of this, man. Deployment lo man ఇది రాయలేదు కదా, అందుకే కొట్టేసింది. ఎందుకు కొడుతుంది ఊరికి ఎందుకు కొడుతుంది కాపమెంట్ నేనంటే. Right, fine, whatever it is. Right. Okay. So now I have basically applied the whole MySQL -AWS. Right. So and then if you scroll down, then I have written it for my Flask application. In our class, we have written it for OpenMRS. In this case, we are writing it for a Python application. Right. So and then we have applied the spec, and after that our application was up. Okay. I was able to see the home page also. Right. I am unable to set the database credentials because I have not set the environmental variables correctly. That was my mistake which I have basically done. Are we clear on all of these steps? Okay. So today in the evening, what we will do is we will have Kubernetes class itself. Okay. But wonderful part will be, right, by following that documentation, I want you guys to do an OpenMRS. Whether you want to do it on AWS or whether you want to do it on Azure is your choice. Okay. I will be here helping you out to do the stuff. ఎవరికైతే నిజంగా చేయాలంటే వాళ్ళే రండి, చూద్దాం అనుకునే వాళ్ళు రావద్దు, అసలు ల్యాప్టాప్ లేకుండా రాకండి క్లాస్. ఓకే. బికాస్ ఇన్ ద ఈవినింగ్ ఫర్ ద 3 hours I'll be available over here, but we will not have a formal class. Okay. Whatever I've done in the classroom, okay, today, let you guys do it, and any doubts which you have, I'll try to resolve them. How is that I have written, so that you will speak about a whole applications journey. Is that okay? So today in the evening, 7 or 6 to 9, we will be having a practice session of whatever I have done. And understand one thing, I will not be doing it. I will be only helping you guys to get your job done. There is already a documentation over there, right? By looking at that documentation, you can use the same Python application. But when I say use the same Python application, please don't copy paste commands. Okay, copy paste చేస్తే అది పని చేస్తుంది కాబట్టి అక్కడ ఉంది. అది చేస్తానికి మళ్ళీ మీరు సాయంత్రం చెడగొట్టుకునే అవసరంలా. Right? But if you want to understand the whole flow, whatever I've done, starting from running the application from Docker to here, I want the people with systems right? As I know, some of you might not have laptops, but who are serious about practice, come here. Who are not serious about practice, Kubernetes అయిపోయింది, మీరు ప్రపంచం కన్నా ఆల్రెడీ 10 మెట్లు ఎక్కువగానే ఉన్నారు, ఈ సాటిస్ఫాక్షన్ తో ఇంటికి వెళ్ళిపోండి, right? In the evening, I want people who want to do the stuff come to the class. Otherwise, you can skip the evening's class. Clear on that? Yeah. But have you seen? I've taken an application. I didn't have anything literally, and I've started from zero, and then I am able to deploy my application onto the Kubernetes, which is basically running in Azure platform. Yeah, it has taken approximately 2.5 hours for me to do this, right? So if your application has 10 services, let us assume we will multiply. It will not take that much time, but 20 hours. 20 hours of one-time job, you are able to deploy a whole of your application to the Kubernetes cluster. And after that, you will be making changes one after the other. So is it not something which we basically look out for? Yeah. So when we started this class, we didn't add anything literally. But by the time I'm finishing, I'm basically running this on Azure. Okay. So there is a documentation of how to run the stuff in AWS, right? In AWS, you have to make some changes. I'll be making this documentation available to you. Okay. So how to enable the service without access. Okay, I'll do one thing. I think I've done this, but uthub.github. Yesterday I said that, right? I'll be giving you some deployment, some stuff where you have this. Oh, this is just, is it? github.com/ oh man, why is it going to gist? Okay. So in here, do I have anything which is called as /openmrs-core? Yes, good. So are you seeing K8s over here? In Kubernetes, I have written a deployment where these things are already available. These are working stuffs. They will work. Okay. So you have a pod, you have a service. I am giving a whole link to this, right? But it doesn't mean that you have to copy paste that and execute the commands and verify that whether they are working or not. I would expect that you would write your own stuff, and when you miss something, go and look into that, right? ఇది రాసేసి దీంట్లో 2-3 అక్షరాలు గుర్తెట్టుకొని అది పెద్దగా ఉపయోగం ఏం చేయదు దానివల్ల, రైట్? సో రెఫర్ ఫర్ Kubernetes spec YAML files. Okay, and now your exercise for this. I have run the OpenMRS application, right? Yeah, I have taken the OpenMRS application and I have run it. Okay, so can you run Game of Life and Kubernetes? Can you run Game of Life and Kubernetes? The Game of Life and Spring Web Clinic and in the same Kubernetes cluster. Okay, Game of Life and Spring Web Clinic in the same Kubernetes cluster after you do this, because here we have database. There is no database needs. Everything is stateless. It doesn't remember anything. So that is very simple stuff. But once you have done this, try to do it. And my recommendation is try to do it in both Azure and AWS. Okay. So if you don't have an Azure account, if you have only one account, that's fine. But if you have an account and if there is a chance, try to do it in both the worlds. Clear on this? There is a whole documentation that is available. I have given you the specs, and in the evening, I'll be helping you out to do this activity, right? So in that case, wherever you are stuck in practically doing it, okay, if this 3 hours is not sufficient, we'll sit for another 3 hours, okay, over the next week. But I don't want to basically tell it like a classroom. I want you guys to do something. When you fail, let me resolve the issues. Clear on this? Okay. So in the evening, ఇంకొంతమంది ఇంకో అడుగు ముందుకేసి సాయంత్రం క్లాస్కి రికార్డింగ్ అడుగుతారు. Evening class will not be recorded. Am I clear on this? So in the evening class will not be recorded, because those are the doubts which people have got while they are doing it. So for the evening class, there will be no recording. Okay, we'll have a webinar session, and once I want to basically log in into your systems, if you want to show me something, I'll be using some of the remote viewer software, something like TeamViewer, AnyDesk, whatever it is, right? So to help you out, guys. So evening's class will not be recorded. ఓకే, ఎవరైతే రికార్డింగ్ కోసం అడుగుతారు కదా తర్వాత రాకుండా వాళ్ళని అనగండి, అసలు కుబర్నెటస్ మిగతా క్లాసులు అన్ని ఒక ఎత్తు, ఆ ఒక్క 3 గంటలు ఒక ఎత్తు, అది రాకపోతే నువ్వు దౌర్భాగ్యవంతుడు. మీకు చెప్తారు కదా 99 సంవత్సరాలకు వస్తుంది ఇలాంటి రోజు మళ్ళీ రాదు, ఇంకా నువ్వు ఈ జన్మలో చూడలేవని. రైట్, దగ్గర దగ్గర అటువంటి చెప్పండి. క్లియర్ ఆన్ దిస్? సో దిస్ ఇస్ వాట్ విల్ బి డూయింగ్. There are a couple of things which I want to speak, and then I'll go to questions. Right. So one thing is basically, ఒకసారి సతీష్ పిలవండి, ఏదో చెప్పాడు నాకు మర్చిపోయాను. సతీష్ ఒకసారి పిలవండి. Okay, so while Satish comes in, it will take 5 to 10 minutes, man. I know I am delayed, but generally I will not be delayed on Sundays, right? So it's okay for one day, right? So Tuesday will continue Kubernetes deployment exercise. Why will I continue your exercise? Alright? If I give an exercise, that is your responsibility, right? Me exercise నేను ఎలా కంప్లీట్ చేస్తానండి? Right? Okay. Please show how to do it on EKS also. I think I have a document there. There is a command there. Everything is present there. You are old enough and mature enough to execute CLI commands. Yes or no? Yes. So the only difference between AWS AKS and Amazon's EKS is, in Amazon EKS, to maintain the cluster, they will charge you $0.22 per hour. Some amount is there. Whereas Kubernetes, whereas in Azure, it will not take it directly, it will take it indirectly. Okay, there is a different way of pricing, but at the end of the day, your monthly bill will be exactly the same. They are not different. Okay, so right.